Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter wave optics. So in the previous part 1 we had solved till the question number 19. In this part 2 of this chapter we shall start from question number 20 onwards. So any doubts if you have in any of the solutions, then please write that in the comment section, which we shall clarify in the subsequent videos. And in any other chapter of physics, if you feel more difficulty, then please mention the name of that chapter in the comment section. Then we shall give more priority on it, solve more and more questions on that chapter. And some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So in question number 20, it is told that if the two slits in Young's double slit experiment are of unequal weight, then the two slits are having unequal weight. Then what will happen? That so then the intensity from these two slits will not be the same. That means the intensity from one slit, if it is I1, and intensity from another slit, it is I2, then I1 will not be equal to I2. That means that the minimum intensity is equal to square root of I1 minus root over I2 whole square. So that is not equal to 0. So it means that the intensity, the minimum intensity is not 0. It means that the dark fringes are not perfectly dark. The dark fringes are not perfectly dark. So option D is the correct answer. Question number 21, it is told the phenomenon of polarization shows that light has transverse nature. The phenomenon of polarization shows that light has transverse nature, since only transverse wave can show polarization. So option B is the correct answer. Which of the following phenomena support the wave theory of light? Scattering and interference, diffraction. Velocity of light in a denser medium is less than the velocity of light in the rarer medium. So the scattering does not support the wave theory of light, but the remaining things, which are interference, diffraction, and the velocity of light, that support the wave theory of light. So 2, 3, and 4 statements are correct. So option C is the correct answer. Then in question number 23, it is told white light reflected from a soap film whose refractive index is 1.5 has a maxima or at 600 nanometer and a minima at 450 nanometer, and with no minimum in between, then the thickness of the film is. So if the soap film has thickness T and its refractive index is mu, then for constructive interference or for interference maximum, for constructive interference or for interference maximum, we should have that 2 mu T, that will be equal to n plus half into lambda, where n is the order of the interference maximum. N is the order of maximum. Order of maximum. And for interference minimum, we should have, for interference minimum, we should have that 2 mu T, that will be equal to n lambda. So here I can write lambda 1 and here I can write lambda 2. Therefore the maxima is obtained for 600 nanometers. So therefore I can say n plus half into lambda 1, that is equal to n into lambda 2. And that is equal to 2 mu T. So 2 mu is 1.5 into thickness, that is T. So now therefore n plus half into 600 nanometer, that is equal to n into 400, and n should be integer, n into 450, n should be an integer. So therefore this would be 15 3s are 45, 15 4s are 60. You can tell 4n plus 2, that is equal to 5n, sorry 3n. Therefore I can say n So let's suppose we say this is n plus 1th. N plus 1th minima is there. N plus 1 into lambda 2. So this is n plus 1 into 450. So this is 46. So this is 3n plus 3. So n will be equal to 1. Therefore the thickness we have to find. Therefore 1 plus 1 into lambda 2, that is equal to 2 mu into T. So therefore we can say 2 into lambda 2, that is 450 nanometer, 10 power minus 9 is equal to 2 into mu 1.5 into T. So 2 and 2 will cancel out, and T will be equal to 4.5 into 10 power minus 7 divided by 1.5. This is 15 3 or 45. So it is 3 into 10 power minus 7 meter the thickness of the soap film. So 3 is the option C is the correct. a cylindrical tube of length, one cylindrical tube there which is of length 0.2 meter and its radius is R, with sugar solution of concentration C to produce a rotation of theta in the plane of vibration of a plane polarized light. The same sugar solution is transferred to another tube of length 0.3 meter of same radius. The remaining gap is filled by distilled water. Now the optical rotation produces so here the optical rotation the rule is that the optical rotation depends only on the concentration of the sugar solution. Depends only on the concentration of the sugar solution, and it is independent of the length of the cylindrical tube. So therefore here also the optical rotation produced will be theta. Option A is the correct answer. In question number 25 it is told the diameter of the objective of a telescope is 200 centimeter. Diameter of the objective. So we have an objective and we have the eyepiece. So here the diameter of the objective is 100 centimeter. What is the resolving power of a telescope? Take wavelength of light as 5000 angstrom. So the resolving power of the telescope that is given as d by 1.22 lambda. So d is 200 centimeters, so 200 to 10 power minus 2 divided by 1.22 into lambda, that is 5000 into 10 power minus 10. The resolving power that will be is 2 by 1.22 into 5 into 10 power minus 7. This will be 2, 6 are 12, 2, 2 and the 2. Yes. This will be equal to 10 into 10 power 6 divided by 5 into 0.61. So this will be 5 2s are 10. So 2 by 0.61, this will be 3.3 approx. 3.3 into 10 power 6. So option C is the correct answer. Then it is told polarized light of intensity I0 is passed through another polarizer whose pass axis makes an angle of 60 degree with the pass axis of the former. Then what is the intensity of the emergent polarized light from the second polarizer? So according to the Malus law, we have that the intensity of the polarized light which comes from the second polarizer, whose pass axis is inclined at an angle of 60 degree with the pass axis of another polarizer. So here the intensity is I0. From here intensity is I0. So through this, how much intensity will come? So that is given as I0 cos square theta. So here theta is equal to 60 degree here. So therefore the intensity which comes, that will be I0 cos square 60 degree, so which is I0 into 1 by 4. It's I0 by 4. So option C is the correct answer. Then in question number 27, it is told that the polarizing angle of glass is 57 degree. The polarizing angle of glass is 57 degree. A ray of light which is incident at this angle will have an angle of refraction as so here there is glass, there is air. So the polarizing angle of glass angle is 57 degree, which is equal to IP. So here what will happen? The reflected ray and the refracted ray will be at right angles. So here we have air and here we have glass. So this angle is 90 degree. So therefore this is IP for reflection. This is reflected ray. Means there is partial reflection and partial refraction. The refracted ray is completely polarized. So this is angle R. Therefore I can say that IP plus 90 plus R, that is equal to 180 degree. Therefore IP, so the angle R, that is equal to 90 minus IP. 90 minus IP. Therefore we can apply the rule, that is that 1 into sine IP, that is equal to so here the polarizing angle is given as 57 degree. Therefore the angle of refraction will be 90 minus 57 degree. So that will be equal to 33t. So option A is the correct answer. Then in question number 28, it's told to observe diffraction, the size of the obstacle should be lambda by 2. To observe diffraction, the size of the obstacle should be lambda by 2, and lambda is the value of the light should be of the order of the wavelength should be much larger than the wavelength. To observe diffraction, the size of the obstacle should be of the order of the wavelength. Option B is the correct answer. The size of the obstacle should be of the order of wavelength of the light used. Then only the diffraction of the wave can be observed. Diffraction can be observed. In Young's double slit experiment, the source is white light. Source is that one slit is covered with red filter, another with blue filter. What shall be? There shall be alternate red and blue fringes. When white light is there, then there will be no interference, since the interference fringes for different colors should be formed at different points on the screen. So there will be no interference. Option D is the correct answer. Then light of wavelength 600 nanometer is incident normally on a slit of width. Is incident normally on a slit of width 0.2 millimeters. The angular width of the central maxima in the diffraction pattern is the angular width of the central maxima in the diffraction pattern is measured from minimum to minimum. So the angular width, that is 2 theta. This is theta, this is theta. So we know that sine theta, which is approximately equal to theta, that is equal to lambda by A for first minimum on the screen. For first minimum on the screen. So therefore 2 theta, that will be 2 lambda by A. So this angular width of the central maxima we have to find, which is measured from the first minimum to the first minimum on the either sides. So therefore the angular width will be 2 into lambda, which is 600 nanometer, which is 600 into 10 power minus 9 meter, divided by A, the width of the slit, that is 0.2 millimeter, which is 2 into 10 power minus 4 meter, into 10 power minus 4 meter, 2 into 10 power minus 4. So this much radians. 2 and 2 will cancel out, and 6 into 10 power minus 7 divided by 10 power minus 4 radian. So this will be 6 into 10 power minus 3 radian. Option A is the correct answer. And then in question number 31, it is told for what distance in ray optics is good approximation when the aperture is 4 millimeter and the wavelength of light is 400 nanometer. So there is something called as Fresnel distance. Fresnel distance. So the Fresnel distance, that is called as ZF, that is given as a square by lambda, where a is the width of the aperture. So here a is 4 millimeter and the wavelength of the light used is 400 nanometer. So therefore the Fresnel distance ZF, that will be given as 4 millimeter, that is 4 into 10 power minus 3 whole square divided by lambda, that is 400 nanometer. So 400 into 10 power minus 9 meter. So this is 16 into 10 power minus 6 by 4 into 10 power minus 7. 4 is 16. This will be equal to 40 meter. So option D is the correct answer. So in Young double slit experiment, if yellow light is replaced by blue light, the interference fringes become wider, brighter. Okay, we have to find that. So that the fringe width beta, that will be equal to lambda d by d. So here fringe width is proportional to the wavelength. So now the wavelength of blue is less than wavelength of yellow. So it means the fringe width for the blue color will be less than the fringe width for the yellow color. So the fringe width, so the interference fringes will become narrower. Interference fringes will become narrower. Option C is the correct answer. So here it is told that in a system of two cross polarizers, it is found that the intensity of light from the second polarizer is half from that of the first polarizer. The angle between their path axes is a system of two crossed polarizers. It's found that the intensity of light from the second polarizer is half that of the first polarizer. The angle between their path axes is the intensity is coming from here and the intensity is coming from here. So here the intensity is I naught by 2, it is told. Whereas from the second polarizer is half that from the first polarizer. So therefore you know that the angle in between their path axes, that is suppose theta. So I will be equal to I naught cos square theta, which is according to the Malus law. According to the Malus law. Therefore, I is equal to I naught by 2. So I naught by 2, that will be equal to I naught cos square theta. I naught and I naught will cancel. So cos square theta, that is equal to half. So cos theta will be equal to 1 by root 2. So theta will be equal to 45 degrees. Option C is the correct answer. According to Huygens principle, during refraction of light from air to a denser medium, during refraction of light from air to a denser medium, the speed actually should decrease, but according to Huygens principle, the speed should increase. So both wavelength and the speed would decrease. Option C is the correct answer. A plane wavefront of wavelength lambda is incident on a single slit of width A. The wavelength is lambda. The angular width of the principal maximum is. So the width of the principal maximum, the angular width of the principal maximum, that is given as 2 theta, that is equal to 2 lambda by A. So option B is the correct. The Fraunhofer diffraction at a single slit, if yellow light illuminating the slit is replaced by blue light, then diffraction bands in the Fraunhofer diffraction at a single slit, if yellow light illuminating the slit is replaced by blue light. So the wavelength of blue light is less than the wavelength of yellow light. So then what will happen? So for nth minimum on the screen, sin theta is given as n lambda by A. For nth diffraction minimum or nth dark fringe on the screen, sin theta is equal to n lambda by A. So the angular width of the fringe, the angular width of the nth bright fringe, that is approximately, that is lambda by A. So when the wavelength will decrease, since the yellow light is replaced by blue light, so the wavelength has decreased. So when wavelength will decrease, then this angular width of the fringes will also, that will also decrease. So it means the diffraction bands will become narrower. Diffraction bands will become narrower. So option D is the correct answer. Then in Young's double slit experiment, two wavelengths lambda 1 and lambda 2 are used to obtain interference fringes. If the nth bright band due to lambda 1 coincides with n plus 1th bright band due to lambda 2, the value of n is. In Young's double slit experiment, two wavelengths. One wavelength is so the nth bright band due to lambda 1 is that yn is n lambda 1 d by d, that is equal to n plus 1th lambda 2 d by d. Means the nth bright band due to lambda 1 coincides with n plus 1th bright band due to lambda. Here lambda 1 is given as 780 nanometer and lambda 2 is given as 520 nanometer. So d and d that will cancel out. Therefore I can say that n into lambda 1 780 is equal to 80, that is equal to n plus 1 into lambda 2, that is 520, and n is an integer. This will cancel, so this will be 2 3 is 6, 2 9 is 18, 2 is 4, 6 is 12, 13 3 is 39, 13 2 is 26. So therefore 3n that is equal to 2n plus 2. So therefore I can say n is equal to 2. So the value of n is 2. So option C is the correct answer. In Young's double slit experiment, slits are separated by a distance of 2 millimeter. The screen is placed at a distance of 1.2 meters from the slits. So this is equal to D actually. So here the screen is placed, and here we have the plane of the slits. These two are the slits. Then light consists of two wavelengths, lambda 1 so lambda 1 the light consists of two wavelengths, lambda 1 and lambda 2. So lambda 1 is 6500 angstrom to 6500 to 10 power minus 10 meter, and lambda 2 that is 5200 angstrom into 10 power minus 10 meter. I used to obtain interference fringes, and the separation between the fourth bright fringes and the separation between the fourth bright fringes separation between the fourth bright fringes, two different patterns produced by the two wavelengths is two different. The separation between the okay, so let's suppose I call it as y1 for the first one, so that is lambda 1 fourth bright fringe, 4 lambda 1 d by d, and y2 that is 4 lambda 2 d by d. So therefore we have to find the value of delta y, that is the separation between fourth bright fringes of two different patterns that is produced by the two wavelengths. So the lambda 1 is more than lambda 2, so this will be y1 minus y2. This will be 4 d by d to lambda 1 minus lambda 2. That will be equal to 4 into d, that is 1.2 meter, divided by d, that is 2 into 10 power minus 3 meter, into lambda 1 is 650, or I could write 65 minus 52 into 10 power minus 8 meters. This is minus 3. So 2 2s are 4. This will be 2.4 into this is 10 power minus 5. That's 3 minus 8. Into this will be 1. This is 13. So therefore, the value of this delta y is equal to 13 4 the 52. That is the 26 plus 3 31. 26 plus 31 into 10 power minus 5, or I can write 0.312 into 10 power minus 3 meter, or I can say 0.312 millimeter. So option A is the correct answer. In question number 39, it is told that a transparent medium shows relation between I and R as shown. If the speed of light in vacuum is c, the Brewster angle for the medium is Brewster angle for the medium is. Brewster angle. So the Brewster angle that is given as tan IB, that is equal to mu, where mu is the refractive index of the medium. So therefore now we are find the ratio. So here y by x, so here the graph, it passes through the origin, the slope is tan 30. So sine r y, that is equal to slope, that is tan 30 into sine r. So therefore sine r, that is equal to 1 by root 3 into sine r. So sine I, so what happens? This is the rarer medium, which is here, suppose, and this is the medium having refractive index mu. So then this angle is a right angle. So here the refractive index is 1, here it is mu. So I can say this is I, this is R. Let us say sine I, that is equals to mu into sine R. So sine I, that is equal to root 3 into sine R. So therefore the refractive index of the medium is root 3. Now you have to find the Brewster angle for the medium. So IB, Brewster angle, that is equals to tan inverse of mu, which is tan inverse of root 3, which is equals to 60 degrees. So option A is the correct answer. And in question number 40, it is told, in Young's double slit experiment using monochromatic light of wavelength lambda, the intensity of light at a point on the screen where path difference is k units is the path difference path difference is lambda is k units. Intensity of light. Okay. So the net intensity is given as I resultant, that is equals to 2 I naught into 1 plus cos delta phi, where the phase difference delta phi that is equals to delta phi that is equal to k delta x. So here the path difference delta x that is equals to lambda. So here it is told that when the path difference delta x is lambda, then the intensity is given as k units. Therefore k that will be equal to 2 I naught 1 plus cos k, that is 2 pi by lambda 2 pi by lambda k, and so this is 2 pi by lambda into delta x into lambda. So lambda and lambda will cancel out. So cos 2 pi is 1. So this is 4 I naught. 4 I naught is k. Therefore the intensity of the intensity of light at a point where path difference is lambda by 3 is so therefore the intensity I dash, that will be 2 I naught into 1 plus cos k, that is 2 pi by lambda into lambda by 3, where the path difference is lambda by 3. So lambda and lambda will cancel out. So this will be 2 I naught into 1, and cos 2 pi by 3 is cos pi minus pi by 3. So this is equal to minus cos pi by 3. Since why it is in the second quadrant where cos is having negative value. So this is minus half. 1 minus half. So this is 1 by 2. So this is equal to I naught, which is equal to k by 4. Option D is the correct answer. So the intensity of light at that point where path difference is lambda by 3 is k by 4. Then in question number 41 it is told, due to Doppler's effect, the shift of wavelength observed, that is delta lambda, is 0.1 angstrom for a star producing wavelength 6000 angstrom. The velocity of recession of the star will. So we know that, so according to the Doppler effect, Doppler's effect, we have that the relative change in the frequency, that is delta nu by nu, that is equals to minus v radial by c. Minus v radial by c. So delta nu by nu, that is also equals to this. We know that nu is equal to c by lambda. So therefore delta nu, so d nu so delta nu by nu also equals to minus of delta lambda by lambda. So delta nu, that will be equal to minus c by lambda square into delta lambda. So that is minus delta lambda by lambda, that is equals to minus v radial by c. So we have to find the v radial, which is the radial velocity, the velocity of recession of the star. This we have to find. This v radial only we have to find. and c is the speed of light in vacuum. So therefore, I can write delta lambda by lambda, that is equals to v radial by c. So v radial, that will be equal to c prime lambda into delta lambda. So therefore, v radial, that will be equal to c, that is 3 into 10 power 8 divided by lambda, that is 6000 angstrom, 6000 into delta lambda, that is 0.1 angstrom. This will be equal to is 3 into 10 power 7 divided by 6 into 10 power minus 6 into 10 power 3. So 3 2s are 6. So this will be 1 by 2 into 10 power 4. 5 into 10 power 3 meter per second, or I can say it will be 5 kilometer per second. So option A is the correct answer. And then question number 42. So two poles are separated by a distance of 3.14 meters. So two poles are separated by a distance of 3.14 meters. The resolving power of the human eye is 1 minute of an hour. So the resolving power of the human eye, that is 1 arc minute, means it is 1 by 60 degrees. The maximum distance from which he can identify the two poles distinctly is. The maximum distance d from which he can identify the two poles distinctly. The two poles distinctly is. So this d we have to find. So the sine theta, this will be d suppose. So sine theta, that will be equal to approximately equal to theta, that is equals to d by d. Therefore d will be equal to d by theta. That we have to find. D is 3.14 meter divided by 1 by 60 degrees. So how much in radians? It will be 1 by 60 into pi by 180 radians. So this will be pi by 60 into 180 radians. So pi I can write it as approximately 3.14. So 3.14 into 60 into 180 meters. 3.14 it will be cancelled. And 18 6 are 48. So 108.00 meter, or I can say this is 10.8 kilometer. So option C is the correct answer. So 10.8 kilometer is the maximum distance from which he can identify the two poles distinctly. Option C is the correct answer. And in question number 43, it is told three Polaroid sheets P1, P2 and P3 are kept parallel to each other such that the angle between pass axes of P1 and P2 is 45 degrees and that between P2 and P3 is 45 degrees. three polarized sheets P1, P2 and P3 are kept parallel to each other. Such that the angle between the path axis of P1 and P2, that is 45 degrees, and in between P2 and P3 that is 45. P2 and P3 that is also 45. If unpolarized beam of intensity, here the intensity of the unpolarized beam, that is I0, that is 128 watt per meter square, is incident on P1. What is the intensity coming out from P3? So the intensity coming out from P1, that will be equal to I0 by 2. And the intensity coming out from P2, let's call it as I2, this is P3. The intensity coming out from P1, that is I1, that is I0 by 2. The intensity coming out from P2, which is I2, that will be I1 cos square 45 degree, which will be equal to I0 by 2 into cos 45 1 by root 2 its whole square, which is 1I by 4, I0 by 4. And the intensity coming out from P3, that is I3, that will be equal to I2 into cos square 45 degree. So I2 is I0 by 4, so this is I0 by 4 into 1 by root 2 whole square. So this is I0 by 8. So therefore the intensity coming out from P3, that is I3, which will be 1 by 8 times the incident intensity, which is 128 watt per meter square. So this is 8 ones are 8, 6 8 are 48, 16 watt per meter square. So option A is the correct answer. Then in question number 44, it's told that in Young's double slit experiment, the distance in between the slits and the screen is 1.2 meters. The distance in between the plane of the slits and the screen, T, that is 1.2 meters in the screen, and the distance between the two slits is 2.4 millimeter. So that is small d. If a thin transparent mica sheet of thickness 1 micrometer and refractive index 1.5 is introduced between one of the interfering beams, in front of one of the interfering beams, here one thin mica sheet is kept whose thickness T, that is whose thickness T is 1 micrometer, and its refractive index mu, that is 1. No, the refractive index is 1.5. The shift in the position of central bright fringes. Shift in the position of the central bright fringe. So the shift in the fringes, shift in the position of the central bright fringe. The shift in the position of the central bright fringe is given as delta y, that will be equal to d by d into mu minus 1 into t. D by d into mu minus 1 into t. Therefore, the shift, that will be equal to d, that is 1.2 meter, divided by d, that is 2.4 millimeter, 2.4 into 10 power minus 3, to mu is 1.5 minus 1 into t thickness, that is 1 micrometer, 10 power minus 6 meter. 1.22 are 0.5, which is 1 by 2, which is 1 by 4 into 10 power minus 3. So this will be 0.25 into 10 power minus 3 meter, which is 0.25 millimeter. So option B is the correct answer. Question number 45, it is told a slit of width A is illuminated by red light of wavelength 6500 angstrom. If the first diffraction minimum falls at 30 degree, so if the first diffraction minimum falls at 30 degree, so for first minimum, for the first diffraction minimum, we have that sine theta, that is equals to lambda by a. So therefore the first diffraction minimum falls at 30 degrees, so here theta is equal to 30 degree. Then we have to find the value of a. So therefore sine 30 degree, that is equals to lambda, which is 65 or 6.5 into 10 power 3 minus 10 divided by a. This is half. Sine 30 is half. Therefore a will be equal to 2 into 6.5 into 10 power minus 7. It is 2 6 12, so this is 13 into 10 power minus 7, or I can say 1.3 into 10 power minus 6 meter, or I can say 1.3 micrometer, or the slit width, that is 1.3 micron. So option B is the correct answer. Then in question number 46, it is told that which of the statements are correct with reference to single slit diffraction pattern. The following are correct with reference to single slit diffraction pattern. So fringes are of unequal width, fringes are of equal width, light energy is conserved, intensities of all bright fringes are equal. So this is wrong. So fringes are of unequal width. So option A is the correct answer, or I can say option 1 is the Correct answer. The fringes are not of equal width. In the Young's double slit experiment, a monochromatic light of wavelength lambda is used. So here I have said that only in case of single slit diffraction the fringes are of unequal width. But in case of Young's double slit experiment, the fringes are of equal width. They are not of unequal width. In Young's, so here it is told in question number 47 that in the Young's double slit experiment, a monochromatic source of light of wavelength lambda is used. The intensity of light through each slit is I0. The intensity of light reaching the screen SC at point P at distance x from O is given by. So here the so here we know that the path difference in between the two waves, that will be equal to path difference in between the two waves, that will be equal to d sine theta. And here sine theta, that is equals to x by root over x square plus d square, which is approximately equal to x by d. So therefore the path difference delta x, that is equals, or I can say it as delta y, path difference delta y, that will be equal to x d by d. So therefore you know that the phase difference, that is equals to k times the path difference. So that is 2 pi by lambda into x d by d. So therefore the intensity of light at point P, that is I, that will be equal to 2 I naught. We know that it is 2 I naught into 1 plus cos delta phi. So 1 plus cos delta phi, I can write it as 2 cos square delta phi by 2. So 2 I naught into 2 cos square delta phi by 2, which is equal to 4 I naught cos square delta phi by 2. So therefore the resultant intensity on at point P, that will be equal to 4 I naught the cos square delta phi by 2, that will be equal to simply that is pi d by lambda d into x. So option B is the correct answer. Then in question number 48, it is told that in case of Fraunhofer diffraction for a single slit, the diffraction pattern on the screen is correct for which of the following statements? Central dark fringe having uniform brightness on either side. Central dark fringe having alternate dark and bright bands of decreasing intensity on either side. Central bright fringe having dark bands on either side. The central bright band having alternate dark and bright fringe of decreasing bright bands of decreasing intensity on either side. Central bright band. So the central bright band having alternate dark and bright bands of decreasing intensity on either side. Okay, so option D is the correct answer. Since for single slit, the intensity distribution, it is somewhat like this. The intensity of the maximas will gradually decrease. Okay. And the central bright band is having the highest intensity. Kind of. which is 4I naught. Then okay, no, this is not 4I naught, this is the maximum distance. So here, question number 49, it is told when a compact disk CD is illuminated by a small source of white light, colored bands are observed. This is due to interference or scattering or reflection or diffraction. So alternate colored bands are observed. This is due to diffraction. So option D is the correct answer. Then in question number 50, it is told for light diverging from finite point source, the wavefront is spherical. The wavefronts are spherical, and the intensity at the wavefront does not depend on the distance. The intensity decreases in proportion to the distance squared. Yeah, the intensity is inversely proportional to the square of the distance from the source. Here the source is placed. The intensity is inversely proportional to the square of the distance from the source. So the intensity decreases in proportion to the distance squared. So option D is the correct answer. Then in question number 51, it is told the fringe width for red color as compared to that for violet color is approximately. So the wavelength of red color, that is approximately 700 nanometer. The wavelength for violet color, that is approximately 400 nanometer. So therefore the fringe width beta, that is given as lambda d by d. So the fringe width beta, that is directly proportional to the wavelength. So therefore the fringe width for the red, now fringe width for the red divided by the fringe width for the violet, that will be equal to the wavelength for red divided by the wavelength for violet. So that will be equal to 700 nanometer by 400 nanometer. So which is approximately 7 by 4, which is approximately twice, which is approximately 2 times. So the fringe width for red color is approximately double. Fringe width for red color is approximately double of the fringe width for violet color. So option D is the correct answer. So here we shall end the second part of this video on wave optics. I hope you have understood the solutions of all these 51 questions on wave optics. So if any doubts you have in any steps of the solutions, then please mention that in the comments section. And please install our Sapience education application, whose link has been provided in the description, where we shall upload some important homework questions on every chapter of physics based on the previous year questions of KCET. So thank you everyone. Bye.